Now come to the question number 9. Roman number 9. In this Roman number there are two questions. There are two parts are there. Here I am not explaining first part. In this Roman I am not explaining the first question, because the first question is also same that of second question. That is why I am not explaining the first question. I am now explaining second question, second part of this Roman number 9. Okay, my dear children. Verify x cube minus y cube is equal to x minus y into x square plus xy plus y square. Here it is asked that we have to verify that equation. Understood the question, my dear children? In the next questions we use this one as a formula. This is also an algebraic identity. The two questions in the Roman number 9 will be used in the future as algebraic identities. This is also can be considered as an algebraic identity. Okay, my dear children. So learn this formula also well. Now to verify this statement, I am taking RHS, right hand side of the equation. What is RHS? X minus y into x square plus xy plus y square. I have taken RHS. Okay, my dear children. Now what is meant by this statement? We have to multiply these two algebraic expressions. In 8th class itself, we have learned how to multiply an algebraic expression by another algebraic expression by using the distributive property. Okay, my dear children. So x into we multiply this expression. So x into x square plus xy plus y square. Understood this term, my dear children? What is second term? Minus y. With the second term, we multiply the second algebraic expression. So minus y into x square plus xy plus y square. Understood this is second term, my dear children? Right. Now here we apply distributive property. So by this x we multiply every term of this expression. Okay, my dear children. X into x square. What will you get here? X cube. Understood this first term, my dear children? Right. What is the second term? X into xy. If you multiply these two, what will you get? Plus x square y. Understood the second term, my dear children? Right. Now come to this one. X into y square. What will you get? Xy square. Understood this third term, my dear children? Right. So here over. Multiplication of these two algebraic expressions is over. Now come to this second term. Here we multiply this algebraic expression by y. Means here also we use the distributive property. So by minus y we multiply each and every term of this algebraic expression. So minus y into x square. What will you get here? Minus x square y. I wrote the term in alphabetical order. First I wrote x, after that y. So minus x square y. After that we multiply this y minus y into x plus y. What will you get here? Minus xy square. Understood this term, my dear children? Right. And finally minus y into plus y square. What will you get here? Minus y cube. Understood the last term, my dear children? Right. Now we simplify the terms of this expression. If you observe, x square y is there, minus x square y is there. So these two terms gets cancelled. That is why I underlined. These two terms are like terms. They will be cancelled. X square y minus x square y gets cancelled. Now come to these two terms. Xy square minus xy square. These two terms are also like terms. We can simplify them. That is why here these two terms also gets cancelled. And finally, what are the terms left here? X cube and minus y cube. x cube minus y cube terms only left here after simplification. Understood, my children? Now, if you observe here, LHS of the given statement, we got LHS. Hence, we can say that the given statement is verified. Understood, my dear children? Remember this question number 9. In this question number 9, both parts are considered as an algebraic identities hereafter. From this moment, we consider them as an algebraic identities. Okay, my dear children? Right. Now, come to the question number 10 or Roman number 10. In this Roman number 10, in this question number 10, there are two parts. There are two questions in this Roman number 10. Here I am explaining the first question. Here I am explaining the first part of this Roman number 10 with the help of the results in the question number 9. Previously I told you the question number 9 is also algebraic identities. Remember well. Okay, my dear children, learn them well. Factorize. Now come to this question. Factorize 27y cube plus 125z cube. This is a given algebraic expression. What should we do here? We have to factorize the algebraic expression. Okay, my dear children. Understood the question, my dear children? I told you many times. First read the question well and understand the question well. Now come to the given algebraic expression I wrote here. Now, how many terms are there? Two terms. I wrote this first term. What is the first term here? 27y cube. I wrote here 27y cube as 3y whole cube. Can we write it or not, my dear children? Right. We can write it as 3y whole cube. In rough work, if you simplify, if you find the value of this term, automatically again you get 27y cube only. That is why I am writing this first term as 3y whole cube. Understood this first term, my dear children? Right. Plus here 125z cube. That is the second term. I am writing here second term as 5z whole cube. 5z whole cube. If you simplify, if you expand the term, 5z whole cube means 5z into 5z into 5z. Automatically again you get the same term. That is why for our convenient we are writing the second term as 5z whole cube. Understood, my dear children? Second term. Right. Now by comparing this expression, now we are comparing this expression with a cube plus b cube. A cube plus b cube, where a is equal to 3y and b is equal to 5z. If you compare this expression with a cube plus b cube, we observe that a is equal to here 3y and b is equal to 5z. Then by using the identity, previously I told you this is also one of the algebraic identities. So totally 10. Before starting the exercise, I told you 8 algebraic identities, and ninth question, the ninth Roman, there are two formulas. There are two algebraic identities, totally 10 algebraic identities. Okay, my children. And one more is also there, we learn it later. So a cube plus b cube is equal to a plus b into a square minus ab plus b square. Okay, my children. Now here a means 3a. In this algebraic identity, I am substituting a value and b value. Then 3y whole cube plus 5z whole cube is equal to a means 3y plus b means 5z into a means 3y whole square minus a means 3y, b means 5z plus b means 5z whole square. If you observe all these terms in these square brackets, I used here small brackets because I am replacing a by 3y and replacing b by 5z. Understood these terms in the second square brackets, my dear children? Right. Now we write this factor as it is 3y plus 5z. This is one of the factors of this algebraic expression. Now in these brackets we simplify each and every term separately in the rough work. 3y whole square. What is meant by 3y whole square? 3y into 3y. Then what will you get? 9y square. Okay, my dear children, understood this term, first term, my dear children? Right. Now minus 3y into 5z. 3 5s are 15 yz minus 15 yz. This is the second term. Understood this second term, my dear children? Right. And now come to the third term, 5z whole square. If you expand 5z whole square, what is meant by 5z whole square? 5z into 5z. 5 5s are 25z square. Understood this third term, my dear children? Right. So these two are the factors of this algebraic expression. Okay, my dear children? Understood? Right. Now come to the question number 11. Question number 11. Factorize 27x cube plus y cube plus z cube minus 9xyz. Here an algebraic expression is given. We have to factorize it. Understood the question, my dear children? By identifying, by recalling the suitable algebraic identity, we factorize this algebraic expression. Okay, my dear children? Right. So here I wrote the given algebraic expression as it is 27x cube plus y cube plus z cube minus 9xyz. Now I will write the given algebraic expression in the form of an algebraic identity, a suitable algebraic identity. So this is the first term, 27x cube. I am writing this 27x cube as 3x whole cube. Can we write it or not, the first term? Yes, right. Plus y cube plus z cube. And come to the last term, 9xyz is there. I am writing this term as 3 of 3x into y into z. Can we write it or not, the last term? According to our convenient, we are writing the terms of the algebraic expression. Understood this step, my children? Right. Now by comparing this expression, this expression become in the form of an algebraic identity. What is the algebraic identity? A cube plus b cube plus c cube minus 3abc. We have learnt that is 8th algebraic identity. Do you remember that one, my dear children? Right. So we are comparing this algebraic expression with this algebraic identity. Then we get a is equal to here 3x and b is equal to y and c is equal to z. Understood this step, my dear children? Right. Now we use that algebraic identity, 8th identity. What is that 8th identity? A cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. This is 8th algebraic identity. I wrote 8th algebraic identity here. Understood this step, my dear children? Right. In this algebraic identity, I am substituting a, b and c values in the next step. Then we get 3x whole cube. A means 3x, so 3x whole cube plus b means y, y cube plus c means z, z cube minus 3 of a means 3x, b means y and c means z. Observe here this term. Here I used small brackets. Okay, my dear children? According to the situation, we have to use small brackets when you are replacing the variable by a number or we are replacing by a variable by another variable. Okay, my dear children. Here I did not use small brackets. Here I used the small brackets. Understood the difference, my dear children? Right. That is equal to A means 3x plus B means y plus C means z. Here no need to use the small brackets. Directly I wrote the A, B and C values. Okay, my dear children? Right. Now come to second brackets. A square is there. So here A means 3x whole square. Understood this term, my dear children? Right. Plus B square. B means y. So y square I wrote directly. Plus C means z. Z square. Understood these terms, my dear children? Right. Minus AB. So minus A means 3x. B means y. Observe this term, my dear children. I have used small brackets. Okay, my dear children? Right. Next term is minus BC. Minus B means y and C means z. Understood this term, my dear children? Right. Minus CA. Last term is minus CA. So minus C means z and A means 3x. Understood this step, my dear children? Right. Now we simplify the terms in these brackets. Here no need to simplify the terms in this first bracket. So I write the algebraic expression as it is in the first brackets. Okay, my dear children. Now come to the second brackets. So in the second brackets, the first term is 3x whole square. If you simplify the first term 3x whole square, what is meant by 3x whole square? 3x into 3x. 3 3s are 9. So 9x square. Understood this first term, my dear children? Right. I wrote this second term as it is y square. And the third term also as it is I wrote here. Any confusion? Any doubt here, my dear children? Right. Now we simplify this term. Minus 3x into y. What will you get here? Minus 3xy only. Understood this term, my dear children? Any doubt? Right. Now come to this term. Minus y into z. What will you get here? Minus yz. Understood this step, my dear children? Is it clear? Right. Now come to the last term. Minus z into 3x. By multiplying these two, what will you get? Minus 3zx. Understood the last term, my dear children? Is it clear? Right. So for this given algebraic expression, these are the factors. The first factor is 3x plus y plus z. That is one factor. And the second factor is 9x square plus y square plus z square minus 3xy minus yz minus 3zx. Here we cannot write the factors of this algebraic expression. That is why we are leaving this algebraic expression as it is. Understood, my dear children? Right. Now come to the question number 12. Question number 12. Verify that x cube plus y cube plus z cube minus 3xyz. X cube plus y cube plus z cube minus 3xyz is equal to 1 by 2 of x plus y plus z, x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. Understood the question, my dear children? This question is also same that of question number 9. We have verified the given expressions. We have verified the given statements in the question number 9. Here also we follow the same steps by taking RHS. Here we take RHS. What is RHS of this statement? 1 by 2 of x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. I have taken RHS of the given statement. Okay, my dear children? Right. We write this part as it is. 1 by 2 of x plus y plus z into, if you observe in these brackets, there are 3 terms. This is the first term, this is second term, and this is the third term. All these 3 terms are in the form of a minus b whole square. Isn't it or not, my dear children? Yes. So we use this algebraic identity to expand each and every term of these brackets. Okay, my dear children? Right. So x square minus 2xy plus y square. By expanding this expression, y square minus 2yz plus z square plus third term, we are expanding the third term. What are the terms you get here? Z square minus 2zx plus x square. Understood all these three, all these are terms in these square brackets, my dear children. By using this algebraic identity, we expanded each and every term. Understood, my dear children, this step? Right. Again, we write this part as it is 1 by 2 of x plus y plus z. Okay, in this brackets we simplify the terms. See here x square at the beginning and last also plus x square. By simplifying, these are like terms. You know, you can simplify the like terms. We can add them. We can subtract them. Okay, my dear children. So x square plus x square, what will you get here? 2x square. Understood this first term, my dear children? Right. Here plus y square, here plus y square. These two are also said to be like terms. We can add them. Well, then what will you get here? Plus 2y square. Understood this second term, my dear children? Right. Plus here z square plus z square plus z square. These two also like terms. So we can add them. So z square plus z square, what will you get? Plus 2z square. I wrote this term here. Understood this term, my dear children? Right. Now we write the remaining terms. What are the remaining terms here? Minus 2xy, minus 2yz, minus 2zx. I wrote the remaining terms as it is. Understood this step, my dear children? Right. Now again I am writing this part as it is 1 by 2 of x plus y plus z. If you observe all these terms, one factor is a common factor. Have you identified the common factor for all these terms? Will be left here x plus y plus z into x square plus y square plus z square minus xy minus yz minus zdx. Okay, my children, understood this step? Right. If you observe this step, this is nothing but algebraic identity 8. 8th algebraic identity. Recollect, bring back to your mind. Okay, my children, that 8th identity. That is nothing but x cube plus y cube plus z cube minus 3xyz. This is nothing but LHS. We got here LHS. And finally we conclude that hence proved. Finally we write this statement. Understood, my children? Right.